So let's learn it through quickly first. Anytime you've got the ratio, start with a ratio. So this means px is equal to 1. Total ratio is 1 plus 2, which is 3. Of which line? PQ. The common line there is PQ. Why is it PQ? When you eliminate x and x, you remain with PQ. So then again, we've got xq. xq is 2 over 3 of PQ. This is what you need to do first. Then let's go to 1a. We are finding PQ. So PQ, we can move that and that. So this will be PO plus OQ. And PO is just the opposite of OP, right? So that will be negative OP plus OQ. So negative OP, just negative 2P plus 4Q. We are done, right? B is PX. Look at the ratio here. PX is 1 over 3 of PQ. So 1 over 3 of negative 2P plus 4Q. You get negative 2 over 3P, and here you get 4 over 3Q. You keep that, very important. Then you see we are finding OX. Let's go to OX. We are finding there. So there are two, we can move like OQ and XQ is fine. You still get the same thing. Or you can move this root and that, or you can move this root and that. XQ is been given, it's here, it's fine, you can still go through. But I would rather use something which I have already found. I've already found PX. So I'm going to take PX and plus OP. Let me put them. So OP plus PX. OP is 2P plus, this is negative this P plus 4 over 3 Q is what we found there. Then when we evaluate this, we get 2P minus 2 over 3 P plus 4 over 3 Q. If we evaluate this is this, we get 6 minus 2, we get 4. So we get 4 over what? 3 P plus 4 over 3 Q. So this is our OX. Now we go to part 2. Part 2 is trying to tell us to show that this is equal to that. But they have given us what OC is. So let's find CQ. CQ. What you are proving that is equal to this. You don't have to start solving this one. No. By giving you this information, show that this is equal to this. So you are going to find the vector. The same way you've been finding these vectors. It's still the same. So CQ is what? So CQ is this line. We can move from there. We can move that and that. We'll still reach that. So we take the root of CO and OQ. So this will be CO and OQ. But take note, they have given us that OC is equal to H or X. So what is CO? We can say that CO and OC are just opposite of each other. So CO is the negative of OC plus OQ like that. So but what is OC? Is this. So we put negative H or X plus OQ is just 4Q. Now what is OX? OX is here, we found it there. So 4 over 3 plus 4 over 3 Q plus 4Q. Then we can now expand. Expanding here we get negative 4 over 3 HP minus 4 over 3 HQ plus 4 and what? and Q. The question is done. All what you are doing is just factorizing what and what is done. Just collect the like terms if you want. So I can put 4Q here minus 4 over 3 then H then Q minus 4 over 3 HP. So if I factorize, what is common here? 4 is common, so I'll remain the 1 minus. Here I'll remain the 1 over 3. I'll remove, even if q is common, but h will remain. Q is common, take it out. Minus 4 over 3 HP. Isn't it what the question is telling us? Isn't right? So it's just the same thing that we've been doing from part A, B, and C. It's the same thing. The only thing is that they are even giving you what to use. The same way you are taking 2 steps to go from there to there, there to there. It's the same thing which is happening to this question. Just that here they have given you the final answer and they want you to show that this is the final answer. The same way, if I gave you the final answer to OX, then I tell you to show that OX is equal to this. You do still take the same steps, right? Yes, and they're just giving you one condition to use this, which they know is somewhere you are going to use it, like the way we used it here, we replaced it there because we found it somewhere there up there.